Welcome to Going in Circles, a Sally Ride EarthKAM lesson. We are going to investigate what keeps an object in orbit. For this lab, you're going to need to get a few items around your home and some items that you might have in your science kit. Before beginning this lab, let's discuss understanding orbits. What happens when a batter hits a baseball? The force of the bat pushes the ball forward in a straight line. At the same time, gravity pulls the ball down. The harder the ball is hit, the farther it will go and the longer its arc will be. Friction with the air slows the ball. To avoid that friction, imagine the batter is standing on top of a mountain that reaches above Earth's atmosphere. She smacks the ball so it moves at 8,000 meters per second. The arc of the ball's fall matches Earth's curve. The ball keeps falling, but it never hits the ground. It falls around Earth. The ball is in orbit. For an object to be in orbit, its forward motion and falling motion must be in balance. A satellite's inertia, the forward motion it got from a boost from a rocket, makes it tend to keep moving at the same speed in the same direction. Meanwhile, Earth's gravity pulls on the satellite, making its path curve toward Earth. If the satellite's forward motion is fast enough, it will not fall into Earth, but will keep moving in a curved path around and around Earth. The balance between forward motion and falling motion keeps the satellite in orbit. Now we're ready to investigate what keeps an object in orbit. Let's get our materials. First, you need 1 yard of string. Remember, 1 yard is equal to 36 inches. You can measure that out and cut that piece of string. Next, I want you to get a small stuffed animal and make sure you have permission. Oh, I'm going to use the bad guy for space, Darth Vader. He's perfect, right?
It's Darth Vader!
Now tie the 1 yard piece of string to your small stuffed toy. To do this lab, you're going to need to find some space. I went outside. So I want you to swing the toy in a circle around your head so that the toy is in orbit. The toy represents an object such as a satellite orbiting Earth. Now, swing the toy more quickly. What happens to the toy's orbit when the toy speeds up? When you swing the toy more quickly, the orbit moves higher. Now, swing the toy more slowly. You can see I speed it up and then let it slow down. What happens to the toy's orbit when the toy slows down? When you swing the toy more slowly, the orbit moves slower. Now let's discuss our results. Did the toy's orbit change when you swung the toy more quickly and then more slowly? If so, why did it change? Yes, your orbit should have changed when you swung the toy at different speeds. When you swung the toy more quickly, the toy had more forward motion, so it moved farther out or into a higher orbit. When you swung the toy more slowly, it had less forward motion, so it fell a bit or moved into a lower orbit. If the toy represents something orbiting Earth, what does the string tied to the toy represent? The string represents the force of gravity balancing the toy's forward motion and holding the toy in orbit. If you let go of the string while the toy was orbiting around your head, what would happen to the toy? Why? If you let go of the string while swinging the toy around your head, the toy would go flying off in a straight line because the toy would still have forward motion, but it would no longer have the string, which is gravity, to balance its forward motion and hold it in orbit. If an orbiting object escapes the pull of gravity, it flies off in a straight line because its inertia causes it to keep moving at the same speed in the same direction. The toy flies away in a straight line, but eventually it falls back because Earth's gravity pulls it to the ground. Besides flying off in a straight line, that toy would have been eaten immediately by my doggies Rudy and Marlin. I hope you learned what keeps an object in orbit. Okay, that's all for me. Take care. Peace.